Okay, in 6.2, it's important that you understand that in the high schools, they really like you to be able to do the algebraic problems with these proofs. Not so much writing the proofs as solving mathematical or geometric statements. So that's what we're going to be doing a lot of in 6.2. Okay, so the perpendicular bisector theorem is in a plane if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So it's taking the point and saying if it's on the perpendicular bisector, then this distance is the same. Okay, so given the point, the distance is the same. What would the converse of the perpendicular bisector say? And is it always, sometimes, or never true? So let's see. The converse of the perpendicular bisector theorem is in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector. So in this one, it's saying, given two lines that connect to a point above another line, if those two segments are equal, so given the segments are equal, then that point is on the perpendicular bisector. So if I had two segments here and they were equal, then this point that matches them would also be on this bisector. Okay, so we're going to use some of either of the perpendicular bisector theorems to find each of the measures in these problems. So the first thing we're going to look for is RS. So we have to look at the picture, and it says from the figure we can see that SQ is a perpendicular bisector because they're giving us these measures are equal and it's perpendicular. So using the perpendicular bisector theorem, we know that the two sides are congruent, and therefore SR equals PS, which is 6.8. Okay, the next one is saying find EG, and that is this whole segment. Okay, so first we're going to look at the givens. They showed us that this side is congruent to this side, and it's also perpendicular. So that's telling us that HF is the perpendicular bisector. So using the converse of the perpendicular bisector, we know that this is cutting this in half, which makes this a midpoint. F is a midpoint, which means that the length of EG would be 2 times 9.5, which would be 19. Okay, and the last one we have from the figure, we can see that BD is the perpendicular bisector of AC because this is perpendicular and these are the same measure. So that tells us that these two sides are AD equals CD by the perpendicular bisector theorem. So we can set those equal to each other and solve mathematically. Okay? All right, there we go. Remember that this is not the solution. They asked us to find AD. So you're going to go do that final step where we plug in the x and get the final answer. Okay, previously you learned that an angle bisector is a ray that divides an angle into two congruent adjacent angles. The distance from any point to a line is the length of the perpendicular segment. So anytime you're finding the distance from a point to a line, it's the perpendicular line that gives you that length. Okay? So now we're going to learn a couple of rules about that. So the angle bisector theorem states if a point lies on the bisector, so we're talking about point D, lies on the bisector of an angle, because it bisected, notice that these are equal, then it is equidistant from the two sides of the angle. This is the same distance as this. The converse of the angle bisector theorem is that if a point is in the interior of an angle, when they say it's on the interior, that means it's inside. Okay, if a point is in the interior of an angle and is equidistant from the two sides of the angle, then it lies on the bisector. That's the converse. So it tells you that it is on the bisector. So, use the angle bisector theorems to find each measure. So be careful which one you're going to use. So we're finding the measure of this angle. Well, if we're given that the sides are congruent, then that's the converse, and that will tell us that the two angles are equal. Okay? This one gives us the congruent angles, so that tells us that using the angle bisector theorem, that these are equal, so now we can set them equal to each other, but we want to find RS, so once we solve for x, we plug it in to this right here, and then we can solve and get 25. So make sure you know which rule you're solving with. Okay, so the last thing we're going to do on this slide is we're going to write equations for perpendicular bisectors. Now, when you look at this diagram, it's all written for you, so I want you to imagine that this red line is not here and the equation is not there. Okay, so the first thing they do is they give you these endpoints, and they graph this line here, the blue line. Okay, now to find the perpendicular bisector, the first thing we have to do is find where it goes through. So we're going to find the midpoint because we know that a perpendicular bisector cuts a segment in half. So to find the midpoint of PQ, we use the midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that gives us a midpoint of 1, 2, which is this point right here. Okay, now the other thing we know is that the slope of a perpendicular bisector will be the opposite reciprocal of the slope of our original line, PQ. So we could use the y2 minus y1 over x2 minus x1, the formula, to find the slope, which is negative 1/3, or we could actually draw it on the, since we've drawn the coordinate plane, we could do this, draw a triangle. This is 2, this is 1, 2, 3, 4, 5, 6, this is 6. It's a negative line. I can see the little man won't finish his race. So it's negative 2 over 6, which equals negative 1/3. So either way, we got our same slope here. So now we're going to find the perpendicular slope, which is the opposite sign, so it's positive, and the reciprocal, so it's 3, which is what they got right here. So now we're going to take that slope and our point M, and we're going to find the equation of the new line. Now, notice that they used the slope-intercept form to find the y-intercept, and that's great. But the problem is, what I noticed on the midterm is that some of you forgot to go to the final step and plug that into the formula with your slope. So I'm going to use the point slope formula with the point 1, 2, and the slope of 3 to get my formula. So I'm going to go y minus 2 equals my slope times x minus 1. I get y minus 2 equals 3x minus 3. Then I'm going to add 2 to both sides, and with the point slope formula, you get the exact formula complete, and you don't forget any steps. So that's all for today. Your homework is related to this, so you should be able to get to it right away.